So we'll get started here. We've got quite a bit to go through. Today is the second in our series of webinars that we are calling the series of Clean Air, Healthy Schools. Last week we started with just some high-level IAQ principles that ground ourselves today, and today we start to get a little bit more technical, although not too deep, in number 2 here. So I'm just going to go through, before we get rolling with the content, a few housekeeping items. So our presentation today, we have about 50 minutes or so of content, so we'll get lots to go through, but we'll leave as much time for Q&A at the end. This session is being recorded, and you'll have the recording will be available afterwards. So we will signal that if there's lots of questions, we'll keep going past 12 o'clock, but it'll continue to be recorded. So if you need to leave right at 12, great. But if there's lots of questions, we're happy to stick around and go a little longer. And those questions and answers will also be recorded, so it'll be part of the video afterwards. So to submit questions, there is in your window, your Microsoft Teams window there should be a little messaging icon at the top that it may say show conversation, and you can submit questions in there anytime you like. All right, like I mentioned earlier, myself and Randy are your presenters today. I don't need to read off our bios, but the real brains behind this operation and this morning is Randy. Randy's been with us for over 30 years in our company and has played many different roles, from service to sales to technical work to product development and everything in between. So he'll be delivering a good chunk of this today. And myself, I'm Ian McGilvery, our Senior Vice President of Corporate Development, and I also have been doing a lot of our new product development lately, and I led our COVID-19 task force, so I've been working with our teams on all the solutions around this pandemic. So thanks for having us here. We're, like I mentioned, this is part 2 of a 3-part series, and next week on the 27th, exactly a week from today, next Thursday, we'll be doing a real deep dive on portable room air purifiers. We will touch on that today, but it's quite a hot topic and lots to know about those, so we're going to do a full hour on that next week. So here we go, and today is all about just optimizing our HVAC and filtration systems that we have in place today in our schools. So we will get started. One quick, just some legal, we're providing general guidance today. The biggest thing to take out of this, we're providing general guidance today, but obviously your facilities and the HVAC systems in your facilities are going to be very unique and quite a wide range. So none of this general guidance today, it'll help you, but it should not substitute for your own assessments of your specific situations, facilities, or nor should it be substituted for the advice of a professional, whether it's from our team or another HVAC professional who's come to look at your specific systems, because everything is unique. So please keep that in mind today. A little bit about us, for anybody that does not know. We're so BGE, we are a Western Canadian indoor air quality and filtration company. We've been around since 1968, family owned and operated. We also, in 2021, became partly Indigenous owned. We are partnered with Fort McKay First Nation, which is just north of Fort McMurray in Alberta. We have 7 branches across Western Canada. We have our headquarters, our manufacturing, and our distribution center in Edmonton. That's sort of the hub. And we have over 200 employees across the West here, and including 16 NAFA certified air filtration specialists and 18 NAFA and or NADCA certified technicians. We'll talk about those in a little bit later today. We have around 3,000 active customers at any given time across many different sectors and industries, and in particularly relevant for today and our audience, we also work with about 120 school boards across the West, as well as dozens of universities, colleges. So we're quite familiar with your facilities, your systems, your filtration, everything in between, and so we're happy to bring our perspective and our experience today to help you along this journey. Okay, so our webinar number one last week sort of set the context and some important principles that we'll bring forward into today, but we do have quite a few participants who did not attend the first webinar and who are here today. So I'll just quickly go through some of the key principles out of last week that we think are important for the discussion today, and for the benefit of those who were not here last week. And then for those of you that were here last week, this may sound a little bit repetitive, but hopefully we kind of reground you in some of these principles. So the first thing, just really important to recognize that we're an indoor species now. Humans, we spend over 90% of our lives indoors, especially in in urban settings. Certainly in Canada in the winters, I don't know about any of you, but the last number of weeks, it would be higher than that. 10% would be 2.4 hours of a 24-hour day. I definitely don't spend 2.4 hours outside when it's minus 30. So we spend a lot of time indoors, and in particular for his schools, obviously a significant portion of that indoor time is for children and teachers and our administration offices in schools. We spend a significant portion of that time. It's estimated kids spend about 1,000 hours every year in the classroom, and teachers and admins would be certainly longer than that. So the challenge with that is we have a lot of contaminants in the air. So our outside environment can create significant contaminants. Certainly in Western Canada, think of forest fires as an example, but everything outside essentially will make its way indoors. So our neighbors, everything around our buildings ourselves, and the infrastructure and systems inside all create contaminants, and then certainly the occupants and the people that come into our spaces create contaminants. So we have to take care of this. And so why is indoor air quality important in schools? This is a nice quote we like from the EPA in the United States. Good IAQ, or good indoor air quality, contributes to a favorable environment for students, performance of teachers and staff, and a sense of comfort, health, and well-being. And these elements combine to assist the school in its core mission, which is educating children. And there's a lot of science around this. Generally, indoor air quality, when we have good indoor air quality, there's really positive correlations around cognitive function, learning abilities. There's literally endless studies that have been done on this, and the science is very conclusive. On the flip side of that, having poor indoor air quality and a lot of contaminants in our air has been associated with a number of health risks. And of course, reduced cognitive function and reduced learning. So lots of science. There's links in here that you can go and check out, but the science is very conclusive around all of this. Now, of course, this is the big one. Now we have this, and we now know, and there's no credible authority that disagrees, that we also respiratory viruses, and that includes obviously SARS-CoV-2, and with this pandemic, as well as colds, flus, anything that's coming out of, or that are respiratory viruses coming out of our bodies, they are airborne, and we're becoming far more aware of this lately, and this has most definitely mobilized us to learn a lot more about indoor air quality. It's quite amazing. We always say nobody knew anything about MERV 13 filters and indoor air quality and all of these terms. We often get blank stares when we bring it up, but now it's a household conversation. In a professional setting, we always say this conversation has gone from the boiler room to the boardroom. We have executives, business owners, heads of states, everything talking about air quality now because of this. But one of the major challenge we have with airborne contaminants is our buildings. Our buildings and our schools, I would say in particular, we've not engineered them for indoor air quality and health to be healthy buildings. We've engineered them for thermal comfort, so we don't get cold or too hot. But generally, ventilation and filtration standards have been set based on the control of only the most basic contaminants, dirt and dust, things like that, and also on generally subjective satisfaction with air quality. So we engineer our buildings and our systems to make sure we don't get too many complaints, but it's very subjective, and it's definitely not engineered to be healthy. A huge driver of this over the last number of decades has been energy efficiency, and of course, buildings are a huge source of energy use in the world, so energy efficiency is very important, but it's been probably the primary dominant factor that's driven engineering of buildings over the last number of decades. And the downside of that is we've created very airtight buildings with poor ventilation, and the air gets trapped in these buildings, gets stagnated, and the contaminants can't make their way out of the building. So, and then there's compounding factors. Not only do we not design the buildings to be healthy, fiscal constraints or, just lack of knowledge has led to, a lot of deferred maintenance. We don't keep our systems up and running. So not only are they designed to not be enough to create healthy buildings, we compound that by letting those systems fall into disrepair. And get dirty and all kinds of things. We're going to talk a lot about that today. And then certainly many buildings and schools over time, they start to get used differently than they were originally designed for. So classrooms are a great example. Schools built 20, 30, 40 years ago, we probably never envisioned that we'd have 35 kids in a classroom. So, the buildings change over time, and our use of those buildings change over time. So, and often we don't change our HVAC systems to accommodate for that. So lots of issues, so the challenge really we face is how do we move from these minimum acceptable standards for indoor air quality and filtration and ventilation to a healthy, more healthy standards. How do we build our indoor environments? How do we retrofit our spaces to become healthy buildings instead of just sort of engineering to that minimum standard? So the good news is we can absolutely get there. And it doesn't have to cost huge amounts of money. It certainly can, and there's lots of upgrades of systems we can do over time, but there's lots of tools we have available, and that's really the rest of this webinar. That's what this is all about. So I would say, while it's this virus that has mobilized the world to care more about indoor air quality and start to work on air quality and improving air quality in our buildings, I'll just say, we're going to talk lots in context today about COVID and how we control that particular contaminant, but these improvements will significantly, the same strategies we're going to use to target that contaminant are the same strategies we would use to improve indoor air quality in general and target all of the contaminants in the air. So if there's a silver lining to this story, it's that we're going to make some long-term improvements that are going to benefit us well beyond the end of this pandemic. All right, so that leads us to our major topics today. So how do we improve the indoor air quality in our schools? Really quickly before I kick it over to Randy, at the end of the day, indoor air quality, there's two fundamental ways you can improve it. We can bring in ventilation on the left we talked about, so we can bring in fresh air from the outside and essentially dilute the contaminants inside and reintroduce fresh air into our buildings. Or the other way, of course, is through things like filtration. We can remove the contaminants from the air. So when we contaminate the air, we have ways to remove it through mainly filtration. So that's, I know that seems like kind of a basic concept, but it's important because it underpins everything we're going to be talking about today. Okay, so this was a framework we introduced last week, and it will continue to be their framework for this one and as well as next week. But the Harvard University has an institute called the Harvard T.H. Chan. The Harvard University has a School of Public Health, and within that School of Public Health, there is a Healthy Buildings Institute. and they do tons of research and provide information on indoor air quality and healthy buildings. It's an excellent resource for those of you that weren't here last week. The link is there. Go check it out. And they've actually customized a whole Healthy Buildings module just for schools. So they call it their Healthy Schools program. And we really like the framework. That it's a very simple framework. So on the left, this inverted triangle, 1, 2, 3. And it's really a framework for guiding indoor air quality improvement. And it's really 3 simple components. There's increasing our ventilation rate, so bringing in more outside air to replace contaminated indoor air, increasing our filter efficiency. So how do we, we can't bring in all outside air, especially in Canada. We've got to heat a lot of it. we can't always have completely outside air. So how do we take the air inside our buildings that's being recirculated and filter it properly? And then supplementing with portable room air cleaners, which we'll talk about in a moment. So very simple framework to guide our discussion. We really like it, and so we're going to reference it. One very important component of this, and we find this is one of the most misunderstood principles of indoor air quality, and these 3 components that they're all additive. So right now, the authorities are recommending essentially, we want to target in our spaces anywhere there's multiple people occupied. We want to get 6 clean air changes per hour. So, and those 6 clean air changes per hour are a combination of these 3 components. So, increasing the outside air. So we bring in outside air to replace the contaminated stagnant air. We can filter the air. In the building that through high efficiency filters, and we can also introduce these portable air cleaners that will also clean or scrub the air. And it's the addition of those 3 things, so 1 + 2 + 3, that we need to do to get us to 6 air changes per hour. So a lot of folks think we have to get 6 air changes of outside air. A lot of people thinking we've got to size room air cleaners to get 6 air changes per hour. No, they're all additive. So that's a really important component. And of course, in a building, how do we get those 3 things? We have our ventilation systems, our HVAC systems can bring in outside air. Our HVAC systems can also filter the recirculated air, and then of course the HEPA air purifiers. So again, this 1 + 2 + 3, to get to 6 air changes per hour is an important concept moving forward. Now, ASHRAE, what does ASHRAE think about this? So ASHRAE, for anybody that doesn't know, they are the engineering body that sets the standards in North America for ventilation filtration. This is 2 letters actually that were recently sent to Alberta on behalf. The one on the left, and we can provide copies of this later, but the one on the left is from the ASHRAE Northern Alberta and Southern Alberta presidents, which I believe a lot of the schools would have seen in December, and it's just clarifying their guidance. And then the one on the right is actually very new. This is actually directly from the chair of the ASHRAE's Epidemic Task Force, clarifying ASHRAE's guidance, and I'm just going to blow that letter up a little bit. And really, what he's talking about is very consistent with the Healthy Buildings framework I just shared. So it's maximizing our outside ventilation, getting our filtration in our HVAC systems to MERV 13, where we cannot get to the 6 air changes per hour from a combination of 1 and 2, recommending that we supplement and get to our 6 air changes per hour through the use of HEPA air purifiers. And again, just clarifying that the 6 clean air changes per hour really is for infection control, and that's based on healthcare best standards. So if you go into a hospital, you're going to have a minimum of 6 clean air changes per hour, and it'll go as high as 12, 15. But we know that at 6 air changes per hour, we make significant improvements to indoor air quality, both for viruses, but also really all of the contaminants. So the ASHRAE guidance is very consistent. I know there's been a lot of confusion about this one. We'd be happy to chat about this more a little bit later, but the guidance is quite clear now. So moving forward here, just again, 1 plus 2 plus 3 to get to 6 will guide us. I know, you know, their ASHRAE's standard for all of this stuff is 62.1, and their last update are quite different standards. You know, MERV 8 is more of a standard than MERV 13. Most of the ventilation rates are not near 6 air changes per hour. In fact, for schools, it's under 3. If you look at the ASHRAE tables for ventilation, they average out to about 2.7, 2.8 air changes per hour. But so the important thing, the rest of the guidance we're providing is not based on ASHRAE 62.1 right now, because ASHRAE has the epidemic task force, and effectively they made some key changes to the recommendations to 62.1, and in particular around the filtration to MERV 13 and the ventilation rates and air changes per hour. So the rest of our guidance today is based on the epidemic task force guidelines, not the regular 62.1 standards. So with that, we're going to dive into each of these layers. And with that, I'm going to get Randy to turn his camera and mic on, and we'll flip over to Randy. And Randy, just take control there as well.
Thank you, Ian. Good morning or afternoon, everyone, depending on where you're at. So we're going to delve into this a little further, like Ian just said. So we're going to start with the ventilation part, and as he mentioned, this is epidemic task force recommendations. So you want to adjust your supply return air fans to the highest possible rate, you know, occupied mode, 100% if you can, depending on your building. Now, some of these things, it really depends on your system and what it can take. So, and while you're doing that, you should adjust the percent of outside air to the highest level possible. I mean, 100% would be perfect, but when it's minus 40 in Alberta, you're probably not going to have 100% outside air. So it all depends on your system, and your staff should know what that can handle, or you know, you can have HVAC specialists help you with that. And if once you get all these levels up there, you may need to have a look at the balance of your system. Increase the runtime. So the epidemic recommends 3 complete air changes of outdoor air between occupied times. Now, if you don't know or do the calculations on that, they recommend just running it for 2 hours in the morning before the students come in or the teachers come in, and then 2 hours after the last person leaves the office. And disable your demand control ventilation and run the fan full time. They also recommend temperature and humidity, which will help control the viruses and the particulate in the air. In the winter, the temperature they recommend 22, in the summer 24. The humidity 40 to 50% in the winter, and summer 50 to 60. Once again, it depends on the part of the world you're in. And if you even have humidity control in your school, it might be tough to get 40, 50% in the prairies in the middle of winter. Dirty coils have a huge effect on airflow. There's not many units I've been in that wouldn't benefit from having the coils cleaned, and they make a big difference in when you're getting as much air as you can in the building. There's an ADCA white paper. They did a test on the impact that coils have on the impact that dirty coils have on airflow. And it's a little hard to see there, but 54% improvement in airflow when they clean the coils, and it improved the CFM in the system. And it went from 300 before in this example of a 8,100 cubic foot space to 460 CFM, which added 1.2 air changes just by cleaning the coils. So just bumping your system up, if you don't look at system hygiene, you might be missing out. And if you're looking at this and you're not sure what to do, you know, there are NADCA certified technicians that can help you with this. They can come and inspect it and see what needs to be cleaned and the proper way to clean it. We do have NAFA certified technicians on our employ if you're looking for that, or I mean, there's lots around North America, and that can help you out. But any of these things that we talk about today, we may be scratching the surface a bit on, but we'd be happy to help you with them and dive a little deeper if need be. So once you've got your system cleaned and as much air coming through it as you can, well, let's talk about filters. So they've recommended upgrade system filters to MERV 13 minimum or greater if you can. 14 is better, the Epidemic Task Force says. Now, obviously, this depends on your system and the size of tracking and the number of stages in your system. There's a lot of variables and every system is a little different. And why MERV 13 or greater? Well, because these little fuzzy balls right there, they ride on aerosol particles that carry it. And I mean, those are particles, so we can take them out of the air with mechanical filtration. And MERV 13 is pretty effective at capturing those. Here's an example of the settling rate. So this is what they've talked about with the COVID dropping out of the air when you cough or talk. Well, the particles that we're talking about are 5 microns down to less than 1. And if you look at this chart, this is, anywhere from 20 minutes to they never settle. And this is a room with no airflow. So if you imagine if there's people in it and airflow moving through it, probably most of those would be in the remain suspended area. And here's another reason for the MERV 13. So MERV 8 is probably around the level or less, depending on the filter that historically you've been using. It takes about 55% of those size ranges we just talked about. Or if you get up to MERV 13, you're actually doing a pretty good job at taking those out, almost 90%. So you would need to run through that MERV 8 filter over 4 times to take out the amount of those size of particles that one pass on the MERV 13 will take out. And once if you go up higher into MERV 14, you're almost at 95%. So you're really affecting the air in that space. Now, I get this question all the time, and everyone talks about, well, a MERV 13 filter might hurt my system. Now, having said that, every system is different, and you need to talk to a professional to confirm that. I mean, it could have a 1-inch track or a 2-inch or 4-inch or 2 different tracks. But in this example, just to show you the difference in pressure drop on a 2-inch filter, which most commercial systems would have. So if you're using right now just a fiberglass disposable panel on a MERV 7 or 8 or a standard pleat, you can see the initial pressure drop is 0.24 to 0.32. Well, a high capacity MERV 13 2-inch pleat is only 0.34. So if you look at the final resistance, you may only be running the glass panel to 0.6. Your system may be able to handle that, or it may be able to go a little higher. You don't have to run the filter to the manufacturer's final recommended. You can change the filter with what your system can handle. So it's not that big of a start to go up to a MERV 13 that everyone seems to think it is. So most commercial systems, I believe, should be able to handle a MERV 13. You just may have to change it a little more often because it's stopping more particles. But if you're concerned, consult a HVAC professional or call us. So the goal of every filtration installation is system performance, not filter performance. You can upgrade these filters, but if they're not sealed, you're not upgrading the filters. So your entire system needs to be looked at. And we're going to look at some of the things when you're looking at this stuff we have and you will actually run into. So from our founder, Gerald Sutton, his favorite line was, if it does not fit, it does not filter. So air takes the path of least resistance. If it can get around a filter, it will. It's going to go through and it's just going to zoom through there and take everything with it. And the more efficient the filter is, the denser it is. So the air is going to try and get around that even harder. And fit is important as efficiency. As I was just saying, if you increase your MERV rating, but you don't make sure it's sealed, it's wasting your money. And here's a good example right here. So a MERV 14 filter with a 1/4 inch of bypass along the side, like we saw in that last picture, can take it down to a MERV 12 filter. And once you get to 3/4 of an inch, which really isn't that much when you look at it, you're down to a MERV 8 and lower. So this is where, if you're going to upgrade to a MERV 13 or 14, you really need to make sure that that unit is sealed. And here's some things we've found in the field that you will see and that need to be addressed. I mean, there can be water damage on the filters. In this case on the right, the filters were installed, but the filter's fallen out. So you need to be in those systems on a regular basis looking at this, because these didn't happen the moment they were installed. This is a number of weeks later. Bypass, this was a good attempt on the left to add a bit of filter there to make sure that it fills the track, but you can put a metal spacer in there, even a wood one, and fill that space or get the right size filter. But you need to fill that entire track with filters. And even on the right, it looks like it's pretty good, but it doesn't come quite to the end. So you have that 1/2 inch gap at the end. So that's dropping you a couple of MERV for sure. So one of the good ways to make sure this is done on a front access system is the clips. Make sure you have clips. In a perfect world, you'd have 4 clips on every filter. Make sure they're not damaged, and they'll hold those filters in place, and they'll push them against the gasketing to make sure they're sealed. And speaking of gasketing, you need to make sure that it's installed correctly. On the filters is a great place to have it, because every time you change the filters, you get new gasketing. You got to make sure that it is applied correctly and it sticks there. The one on the left is obviously falling off, and the one on the right, there is gasket there, but you can see it's deteriorating, and it is behind the clip. It should, in a perfect world, be in front of that. So if you had that on the final filter, every time you put the filter in, you get new gasketing. So it's sometimes you forget when you're doing it to change that gasket, and you only see it when the filter's not in there. And in a side access bank, there's a lot of easy ways to seal it, to make sure the air is going through. You can tape in between the filters. That's perfectly fine. You can caulk in between the filters if they're going to be there in a while too. But one of the simplest things is, even on the side axis, like the picture before, put some gasketing on the sides of the filters, so when they meet, it seals that. Side access units can be hard to seal, so do the best you can to do that. So this is a perfect storm of a unit that we ran into. So the bags are in sideways. With pleated filters or pocket filters, you should try as best you can to make sure that they're vertical, not horizontal. The gasket is falling off of the filter, but on the good side, they have gasket on the sides of the filter. The spacer is actually stuffed in the tracking instead of put in. I'm not sure why, but they just threw it in there. The tracking is very dirty. I mean, this is the air that you're breathing in, and keep it clean. Show your pride in your building. And the filters actually don't come to the door, so there's probably a 2-inch gap there. So these are actually MERV 13 filters. They're probably about a MERV 6. But the door gasket is in great condition. So there are good things, but all these things is what we're trying to say lead to the air going through the filter and working and getting your money's worth out of your filters. And damaged filters. I mean, some of these filters were damaged day one when they were first installed. If you leave that, you could have anywhere from 3 months to 3 years of particles going through this filter, and the size we're talking about. So if a filter is damaged at install, change it right away. And during your inspections, if you see this damage, change it. And that's why you need to get into the units. So filter change out. The filters do become more efficient as they load. So you don't want to just change them every 2 weeks because you think you're doing your due diligence by changing them more often. They do get to a point where they will offload, and where energy makes it not worth it to keep it in, but they do get more efficient. So keep them in to the optimum time, and we can help you with that, and HVAC professionals can. Use MagnaHelic gauge. In a perfect world, every filter bank would have a gauge on it so you could see what the pressure drop is. And those, you can add those to units too. They're not something, if you don't have, that you've lost out. You can add them to units. Visually inspect the filters. You got to open the door and look at what's going on inside, because as the picture before, if one fell out, you wouldn't know it if you didn't open the door. And use the status log. So you put it on the side of the unit, write down when it's been changed, and it gives you a history of how often you're changing them, and a good idea what's going on in there. You should, the filters should be considered dangerous. Well, not life-saving dangerous, but you should consider they could all have COVID or other viruses in them, absolutely. So you want your PPE, you want coveralls and gloves and goggles and a mask. You want to take those filters out and put them in plastic bags while you're in the unit or beside the unit before you take and wander through the school or the facility with them. Keep them sealed and dispose of them, but treat them with respect, because you don't know what's in those, and they could have been in there for a number of months or years, and it could build up in there. Training and certifications. The National Air Filtration Association has a certified air filtration specialist program. As Ian mentioned earlier, BGE currently has 16 CAFSs in our staff. And there is a NAFA certified technician program also, which we're qualified to give to your staff, so that they will understand the importance of the filters and changing them, and the way the system works, and sealing, and everything I've talked about. So any of this, if we can help you with, we'd love to. We also have 18 NCTs on staff too, to do some of the work if you want. So all of this is things you need to do before you start looking at everything else. Make sure you got as much air going through and as clean as you can before you start everything else. But this is the place you need to start, and then move on from here. So I'd like to give it back to Ian, and he can carry on from here.
Sounds good. Thanks, Randy. Okay, so our last, this will be a really quick flyover, because we have a full hour on portable air cleaners next week. We've been doing a lot of installs of those things. I've learned quite a bit that we want to share with the schools, and but I will do a fairly quick flyover of this stuff in case you can't attend next week. And then we'll just finish off with some closing comments on how we can go about starting on all of this. So, so yeah, once again, sort of the ASHRAE Epidemic Task Force again has suggested, again, we go to work on number 1 and number 2, so those 2 sections that Randy just mentioned, and then, and I'm going to talk a little bit about this. Doing ventilation assessment to figure out how many air changes per hour we can get with either like our HVAC systems, and of course natural ventilation is great, opening windows and doors, but unfortunately where we live, it's tough to do that a lot of times. And so what we want to do is try to get to that 6 air changes per hour inside the space, and the recommendations from ASHRAE are to supplement where possible with air cleaners to get there. So we've talked about 1, we've talked about 2, or 3. Again, just to remind everyone that they're additive. We want to get to the 6 through a combination of all of these things. So why is ASHRAE and others recommending the HEPA purifier? So these at a basic level, and again next week we'll go through lots more of how these work and the guts of them and why why they work. But the first and foremost, they add additional clean air changes per hour by removing contaminants directly from the air. This technology has been around for a long time. They're quite effective at cleaning space in right in the rooms. In fact, in the industrial space, we see this exact same technology for, they call them emergency gas scrubbers. So if there's leaks of dangerous gases, we can seal off the area, deploy these types of units, and they scrub the air. They're very, very effective. So we get to bring that technology, out into into regular spaces now, but it's well-developed technology. There's multiple layers of increasingly advanced and efficient filtration inside of these units. Obviously, the final layer inside of these things is a medical grade HEPA filter that really can get to the smallest particles and the very smallest of aerosols. So with a combination of all of the filtration inside of these units, we're able to capture virtually all the contaminants out of the air. They're very effective at scrubbing, not just obviously viruses, aerosols, but particulate matter, volatile organic compounds. They're great with smoke. A lot of these units have a layer of carbon filtration in them that are great for forest fire season. Certainly other viruses, cold, flus, all of that's mold, bacteria, everything. So they're great. The point of this is they're very effective on the airborne aerosols and viruses, but they're also really helpful units going forward beyond pandemic. I mean, certainly colds and flus are always around, and this virus is going to turn into a seasonal flu type of thing as well. And so these things are really effective well beyond the pandemic. So don't think that the investments in these units are a waste, and they're really good enhancements to indoor air quality for our health and our healthy buildings. They also increase air circulation in the room. So when used correctly, they can create quite beneficial airflow patterns inside the room. We got to be careful. They can create detrimental airflow as well inside the room. So we'll talk some more about airflow patterns next week, but they're quite flexible to be able to create good air circulation inside the room and airflow patterns. And the fact that they're portable, most of them, we'll talk next week, there are permanent mount ones and ceiling mount ones, and you can do permanent ones on the walls as well and things like that. But we really like the portable ones just because they're so flexible in deployment. You can use them, you can move them to different spaces. We've had a couple schools say, hey, these would be great during exam times when we put lots of kids in different spaces for exams. We can deploy these things around the facility for different purposes. So they're great that way. Now, we talked about this, they're supplementing to get us to 6 air changes per hour. So that obviously begs the question, well, how do we figure out how many air changes per hour we've got today out of our HVAC system? And we're always cautious with customers to say, there's spaces where you're probably doing quite well with your HVAC mechanical, and so why deploy them in areas that maybe you don't need, or if your budget is limited and you can only target certain areas, you want to be able to target the ones that have particularly low ventilation and not have to spend money on ones where you're already getting your 6 air changes per hour. So that leads us to ventilation assessment. Now this is a complicated topic. There's many different ways to do ventilation assessment. We're doing lots of this work right now with schools and offices and all this stuff. Now there's some very advanced methods that we can use with different technologies, but there's also simple, we call it the desktop method. Now, I'm going to just start with this. This is definitely not perfect nor super scientific, but it is an acceptable method for initial ventilation assessments. At the end of the day, I'm not going to go through all these details, but you've got an HVAC unit. We should know, or we can find out the CFM ratings on that unit. That unit will supply. Sometimes there's one that supplies one space, but typically they're distributed, and they'll supply different zones within your buildings. And so if we can figure out essentially where that unit, what set of rooms or spaces that unit is supplying, we can do basic calculations, and assuming the system is reasonably well balanced and we're getting relatively even airflows into all the spaces that it's supplying, we can do calculations to estimate air changes per hour. So that doesn't require any technology and monitors and things, and it's a reasonably acceptable way. It's a method that a lot of facilities have been using. And then certainly over time, there's advanced methods. So one of them, CO2, is a very good proxy indicator for ventilation, because as you put 35 children in a classroom as an example, we know generally sitting how much CO2 a human being, both kids and teachers, adults, will exhale. And so we can get baseline measurements of CO2 in the room and then do calculations. So we're going to go into this quite a bit next week. Again, we'll show you some examples and case studies of rooms that we've calculated, but it's a well-accepted method for getting at your ventilation rates as well. And then, of course, there's really advanced methods that we can perform. You know, we really want to get scientific about this through bolometers and anemometers that we can deploy and get some really scientific calculations. But at the end of the day, really what you're trying to get at is, you know, the different rooms in your facilities, and, you know, I call this a simple example of a ventilation report or summary across your facility. So you want to get an idea of where across the facility your ventilation rates are sitting, and then this is a way to prioritize the work. You know, we should be concerned about the ones that are going to have 1 or 2 or 3 air changes per hour if we want to get 4 to 6 or get close to that 6 as possible. And so it gives you, if I color coded this one, it gives you a really quick priority mechanism to go to work on this stuff. So that's really what you're trying to get at inside the facility. So I'd say start simple and verify it over time. You know, the desktop method, just calculating based on your, the throughput of your units. You can start there, and then over time, maybe consider some of those more advanced techniques to maybe verify the desktop calculations that you did. And you can chip away at this over time in the facility. So once you figure it out, what have we got from our air handling units, then the difference we want to make up with the room air cleaners. Now we're going to go deep into this next week, and we're getting a little short on time as well. But just a really quick sort of caution on these units. So they're typically, when you look at the specs of these units, they'll have a fan CFM rating. So if we look at this one, the small one on the left, which is quite typical, a lot of these type smaller units have been deployed in classrooms in Ontario and Quebec. They'll have a fan CFM rating, so in this case it's 400 CFMs, but then there's a tested, it's called CADR, the Clean Air Delivery Rate, and that is, the manufacturers should be sending these units away to get tested, and that is a measurement of actually how much air is being cleaned by that unit. So you'll see is quite a significant drop, because this fan speed is the measurement of how much the fan is blowing, but without any filters in it. So once you load the cartridges in there and load the filtration into it, obviously it drops significantly. So you got to use a CADR, and then I've shown this 400 CFM unit goes down to 200 CFMs on CADR. But then we also have yet to see any unit that could ever be run on high in a classroom. They're just too noisy. So realistically, in a classroom setting, most of these will have, some of them have variable speeds, but they'll have a top speed, a medium speed, and a low speed. So medium is quite reasonable. But again, you see some dropping from the high speed to medium speed. In this case, drops your 200 CFMs down to 110. So just got to be careful in sizing these things. There's a bunch of other considerations we're going to look at next week of how to size these properly. But that was one I just wanted to highlight, and there's one thing you took away. And I will say we are seeing a lot of very undersized units in facilities. They rushed early in the pandemic to go buy them. They think they're getting 3 or 4 air changes per hour, and at best they're really getting 1. So just be careful on these things, and they need to be sized properly. Other considerations, I already talked about noise. Most of them can't be run on high speed. Placement in the room to optimize airflow patterns. We talked a little about that earlier. We're going to go into that in detail next week, but just quickly, 2 smaller ones can often be better than 1 bigger one because you can use it to place and create optimal airflow patterns within the rooms. So, and then remember, this is a piece of equipment. They're very simple. They're designed to run for many years, but they're a piece of equipment. So like any other equipment, you have to inspect, maintain them, and then obviously they've got mechanical filters in them, so those filters have to be replaced. So just make sure you're considering that in your total cost going forward. And like I said, we're going to do much more next week. We've got a whole hour next week dedicated to purifiers, and we're going to dive deep into that, all of that. So you can join us then for more on that. Okay, so just finishing off here with just a simple management framework that you can use to go about all of this work. So we use this on our own facilities and with our customers and our service teams where we go and we're taking care of this work on behalf of our facilities. But it's a great framework that we thought we would share, just that you can use as a way to go about all of this. So it just starts with there's 4 steps: assess, go assess your systems, then make a plan based on your observations and those assessments. Start chipping away at that plan and make sure you're managing it over time. So really simple, assessment. We talked a lot about that today. So how do you assess your systems, assess your filtration, do ventilation assessments? So it all starts there because we need to know where we're starting. And we call this our assessment report. We can help with these assessments. Your HVAC mechanical contractors can help with these assessments, and you can perform them yourselves. There's a lot of this work you can do yourself. So, but it all starts there because now, based on those assessments and where you found deficiencies and opportunities to improve your indoor air quality, make a plan based on that, right? So that you just want to itemize things, prioritize them. We showed as an example the ventilation assessment, how we can even color code and target those areas that are have really poor ventilation. But it's all about planning and prioritizing. So create a plan, and then this is really important: communicate. So we're particular in schools, we're seeing a lot of you are under pressure because you've got parents and different stakeholders and things saying, what are you doing about air quality? If you start with the plan and communicate and say, here's where we're at, here's what we're going to be working on, we are seeing it's buying time. I think people will appreciate that you have to work at this over time, but not knowing anything, they're going to panic and think you're not doing anything. So communicate that plan, then start delivering and chipping away at the items there. And as you are making improvements, report progress back, right? Most of you would have we have kids and we get monthly newsletters from the schools and sometimes notes from the school board. So just communicating the progress that you're making and the steps you're taking is a really good thing, again, to buy you time and allow you to work on this over time. And then just make sure, again, these are mechanical systems, they change, the filters fill up with contaminants and dirt, and so just make sure you have a really solid maintenance monitoring plan. You got to continuously assess all of these things as you go. So simple framework. And if you need any help planning this or the assessments or anything like that, we are definitely here to help. So we'll just wrap up. A couple final thoughts. Just play the long game here. I know, again, a lot of you are under pressure, but this will be a journey. There's work to do. We have some schools and boards that started on some of this stuff 12 to 18 months ago, and we have some just starting now, and that's okay. I think if you start with the assessments, you communicate what you're doing, and you buy yourself some time, and then you can work on that over time. And again, just stressing the communication. Make sure you're communicating as you're going, but don't rush it. We believe, obviously we live this stuff every day. We're also very familiar. The last presentation last week, I gave you a link to a podcast episode that the chair of the ASHRAE Epidemic Task Force, and we're starting to see signals that MERV 13 from MERV 8, and the higher air changes per hour. We may not stay at 6, but certainly the question we have is the public, now that we're so aware of all of this, do we ever think that people are going to want to go back to MERV 7 or 8 filtration once we've gone to 13, or do we think we're going to want to go back to 1 or 2 air changes per hour Likely not. And so we are definitely seeing movement that, future updates to a lot of these standards will probably see some fairly significant improvements. So the message here is just don't think that you're wasting effort and dollars and everything, because I think we are seeing a movement to healthy buildings, and we likely will not go back from it. So these are good investments for the long term. And one final thought I'll leave you with, there's a great great book by the fellow Joseph Allen, who runs the Healthy Buildings Institute at Harvard. He also is a co-author of a book called Healthy Buildings, and there's a great quote in there that the person who manages your building has a bigger impact on your health than your doctors. So we've got lots of important work to do. You have important work to do in your schools and facilities, and we're here to help you get started on this. So thank you very much. That is the end of our content. Sorry, we wanted to leave a little more time. So like I said earlier, we're about 3 minutes to 12. We will go past for Q&A if there's questions, and they'll still all be recorded. So feel free to pop your questions into the chat, and we can take those right now. Or if you have to go, then please do. So team, it says the chat has been turned off. Oh, no, it's maybe since back it's turned back on. So it's all going there. Randy, I'll get you to turn your camera on for questions here as well. I don't see any questions coming in.
You must have done a really good job explaining it.
Yes, you did. All right, folks. Well, I hope the technology is not broken, but we were close to 20 minutes Q&A last time. But if there's no questions on this one, maybe we'll wrap up. Oh, Corey, do you help with air quality certification? So there's lots of certifications, from BOMA Best to LEED to Reset to Well Building Standard, all these different things. So yes, we're not experts in any of those systems, but they're all generally, they work on point systems, and most of those are not only, they're not just air quality, they have all kinds of other healthy building measures. But certainly for the air quality ones, we work with a lot of our customers, effectively to make the changes and earn the points, if you will. So yes, we do that, and we also do continuous indoor air quality monitoring, and we have those types of devices. So we can actually make the invisible visible and help you get eyes on your air quality inside your facility. So that's often a big step as well. Follow up from Corey there. I'm a HVAC R, or is that third party? I'm not sure I understand that question. Corey, if you can, I don't know if you can clarify that one. I'll go to John's question, and then we'll come back to Corey if you can clarify that follow-up. Okay, so John, are there any studies addressing whether or not a virus can survive a pass through an air system from room through ducting and air reheat and back to the room? So that's a great question. All the research that I have seen so far is we don't know for sure. They have certainly found, particular buildings that are pulling the air from one room, recirculating it into another. They are seeing a move, but how much of it passes through, how long the virus survives, that science is still inconclusive. So the recommendations right now are based on, we'll call it precautionary principles, they'll call it. So saying, because we don't know for sure how much of it will pass through the system, at what dangerous levels of concentration. That's why they're saying until the science evolves on that we should assume that it does, and do everything we can to capture that stuff. But I mean, the aerosols and these particles, I mean, they will last hours and hours and hours in a room. So Once they enter the system, if they do, obviously, we don't know how far they'll travel and through there, but that's generally what the guidance is based on. Oh, Mike mentioned, yes, other certifications, NAFA Clean Air Awards, that's another one. So NAFA has and we have quite a few of our school customers who won Clean Air Awards over the years from NAFA, so that's another good one. Corey mentioned U of A is doing that study. Yes, they are. They were early. U of A was early recipient of some federal funding quite early in the pandemic. That's a great point, Corey. I haven't heard anything out of that study yet, but they've the University of Alberta. They have set up test labs and test ducts and the HVAC systems, and they're trying to measure and figure out how that virus is moving through the air. So I've not heard any updates from that yet. But Amanda, how long, and then Corey, your follow-up will get there. So how long of a measurement period do you recommend for in-room CO2? That's a great question. I will quickly go back to, and I'll show you why. There was a slide I had earlier here on CO2 measurements. Where was that? Okay, so this graph on the right is a week. So it's 5 business days. So your first bump there is, your first mountain there is Monday, then Tuesday, then Wednesday, then Thursday, and Friday. You want to get at least, I would say at least a week with normal sort of occupancy, because there are definitely anomalies. I showed a pretty easy one here. It was very consistent over those 5 days, but you will get spikes. And so the problem, if you said just did it one day and it was anomaly, it was either really high or really low for some reason. So you want to try and, I mean, the more data, the better, obviously, but we recommend at least a week to try and get a trend. Like this one, we can reasonably say, and that, for our calculations, we could probably use 750 to 800 because we were able to see it. So I would say at least a week. And the other thing too, you don't have to go room by room by room by room. So for example, I talked earlier, if we know we have a set of 5 classrooms that are supplied by 1 unit. If you want to be conservative, go to the one at the very end of that HVAC run that you likely believe has the least circulation in it. Do the tests in that room, and for now you could apply that across the 5 and just see were we way off with our desktop calculations, or were we close? And then so if you thought of take a school with 20 classrooms, you did that, and let's say you had 4 units, 5 rooms each. With 4 monitors in a week, you could get a pretty good sense of what's going on in the building in different rooms. And then over time, just move those monitors, and you could test every classroom if you want. So, but I would suggest definitely a week. Corey's follow-up. My question was pertaining to NAFA certification, as I'm an HVAC-R mechanic. Yes, you did answer. Okay.
And yes, we can give you the NCT designation.
Okay. Jesse, is there available assessment or research on the risk of exposure during HVAC filter changes, or is a recommendation based on common sense? Randy, do you want to?
I don't know of any specific tests on that. I'm sure they've done some research on them, but it's generally common sense, because it really depends when the last time or if COVID hit that filter. So it's hard to make sure, but you just assume it is because it could be there.
Yeah, and I would see, to your point, I would say right now it's probably common sense. And we do. There have been tests. Actually, Ashray mentioned this in a webinar they did about 6 months ago. I was on. They said if you're worried about it, and they were talking as well the room air purifiers, because those will, if there's somebody sick in the room, those will obviously capture lots. If you're worried about it, they do know that it will die. It'll die on or in the filter within a day or two. So they said if you're really concerned about it, obviously it's hard to turn down your HVAC systems for 2 days, although I guess on the weekend, but you can let it. They were saying the purifiers, as an example, you could turn it off for a day or two, and be reasonably safe that once you go to pull filters out, there won't be any live virus in there. But obviously, common sense, PPE is probably a very good idea. David Turner, is there data available from CDC on how much of a known quantity of COVID virus is actually caught by one pass-through MERV 13? Yes. Oh, CDC. I don't know specifically if it's CDC or not, but the chart that Randy showed early, I'm trying to get back to there, was ASHRAE published that chart, and they had they were mentioned in the notes along that chart that like they had consulted with various, I have to check who exactly they worked with on the study, but you know, they've estimated a range of size of aerosols that are the most, that contain the highest viral load, and they believe that to be, you know, just under 1 micron up to about 3 microns. And so I believe that chart we showed with the MERV 13 at 85%, it was in that that 1 to 3 micron size. But we could certainly follow up with you, David, and point you to that reference with ASHRAE. And I believe they talk about who, what studies they referenced and who they worked with to come up with.
Amanda just answered your question for you there, Ian.
Oh, oh, there we go. She found it on CDC. Okay, well, thank you, Amanda. 0.3 to 1. Yeah, so that's the smaller ones for sure. They believe there's a pretty good size of, or pretty good concentration of the 1 to 3, which is at 85%. But yeah, on the smaller ones, it's still 50%. And again, that's why ASHRAE is saying MERV 13 or higher, or the highest possible, because of 14 and certainly 15. And we do have schools, especially if they've been built in the last while, with two-stage systems that can go to 14. 14 and 15 certainly start to get more efficient at that 0.3 and to 1 size as well. So I think, unless there's any others, that looks like we're getting close to the end of our questions. So unless any last minute ones come through here, Randy, we can wrap up.
And if you still have questions that you want, feel free to message us or email us or go to our website and send us one, and we can answer it on the side or give you a call and talk to you personally too.
Yeah, happy to help with any of this. Good luck, everybody, with this work. And again, if you're interested in much deeper dive on room air cleaners and oh, sorry, Corey asked if we were in Edmonton or Calgary. We are both. We're in Vancouver, Prince George, Fort McMurray, Edmonton, Calgary, Saskatoon. We also have a representative in Regina, thank you, and Winnipeg. So we've got folks all over that can help. Oh, I meant where can I reach out to you? Oh, me, Randy. Yeah, Randy and I are in the Edmonton branch. I'll put our emails in the chat here if you'd like.
I'm actually in the Calgary branch, but I'm in Edmonton often.
Oh, did I say you were in Edmonton? Sorry, I meant Alberta. Yeah. I meant Randy and I are in Alberta. Yeah, you're Calgary and I'm in Edmonton.
And we appreciate that you're a loyal customer of BGE. Thank you.
Yes, we do. Thank you, Corey. All right, thank you, everyone. And again, air cleaners next week if you like, and we'll sign off here. Thank you very much for your time.
Thanks, guys.